I asked this question a few hours ago. A lot of persons attempted the question. Some got the answer, others did not really get the answer. So let's solve the question to know those persons that got the answer and those that failed the question or did not get the answer. An electric heater dipped into 500 grams of water in a plastic beaker raised the temperature from 20 to 50 degrees Celsius in 3 minutes. Determine the rate at which heat is given out by the heater. SHC of water is 4,200 joule per kilogram per Kelvin. Now, take a good look at the question and then you notice that what we have here in actual sense is that there is energy conversion from one form to another. An electric heater. Electric, that's obviously electric energy, right? Now, this heater was dipped into 500 grams of water in a beaker, which raised temperature from 20 to 30, meaning electric energy was now converted to change the temperature. That becomes electric energy converted to what now? Heat energy in 3 minutes. Determine the rate at which heat is given out by the heater. So this is a clear question of energy conversion from electric energy to heat energy. For heat energy, H is given as MC change in theta. For electric energy, it is given as, there are different formulas for electric energy. One of those formulas is E equal to PT. So when I marry these guys together, I have PT equal to MC change in theta, right? Now, when you say rate, the word rate represents power. In case you do not know, take a look at the options. Joule per second, joule per second, joule per second, joule per second. So whenever you have joule per second in this format, that means that you're talking about energy. Think about energy over time. Watch. What is energy over time? Let's say you do not know. But because energy is joule, time is second, this becomes Jx minus 1, which is joule per second. All right. So based on what we've said here, that means whenever you see joule per second, you should think of energy per time. And energy per time is power. So that's why I know that what I've been asked here is power. So in this case, now to solve, I'll come out and say, they ask me for the power in this case, I'll come out and say power is equal to MC change in theta over time. Power is M. M is 500 grams. We must convert from 500 grams to kilogram. This is half of a kilogram. That becomes 0.5. C is 4,200. Change the temperature 20 to 50. So it was 20 initially. Because of the electric energy, it changed to 50. That means that the electric energy was able to increase the temperature by 30%, or rather by 30 degrees. So 50 minus 20 is 30. Write it down. Then the time. They say 3 minutes. You cannot solve in minutes. After all the options are joule per second. So you must convert from minutes to second. If a minute is 60 seconds, that means 3 minutes should be what then? 180 seconds. So you come out and write 180 seconds. All right. After doing this, now you can solve. 30 year 1, 30 year 6, right? 0 cancel 0. You are left with P equal to 5 times 420 over 6. What can go? Now, 6 can go into 42. 6 can go into 42. 6 into 42 is 70. So I'll come here and say P is equal to 6 here 1, 6 here 70. That becomes 5 times 70. Your answer is 350 joule per second, which is option A. Not all questions you have to waste your time in the exam solving. There are some formulas you have to know. When you see the question, you just know automatically that this is the formula that works it. So if in second instance, we do not have the specific heat capacity of water, that was not given the question because we don't need it. What we need in this case now is the latent heat of vaporization of water. So how do we solve this? It is pretty much the same as the way we solved the first one. All right, the same thing. Electric energy converted to heat energy. Now watch as I solve this. A heating coil rated 1000 watts. That means the power is 1000 watts. Is used to boil off, that's mass now, 0.5 kg of boiling water. The time taken to boil off the water is dash. So we need to look for the time taken. So the time is what we need to know. And of course, we have this constant here, which is latent heat of vaporization. So this time around, we are not trying to change the temperature of water from what it was before to something new. We just need the water to boil off, to evaporate, or rather to vaporize. All right. So to solve this, the formula becomes PT, which represents electric energy, to MLV, which represents the formula for latent heat of vaporization. Because what I need in this case is time, I'll make this T subject formula and say T is equal to MLV over P. All right, so T is equal to, what is the N? 0.5. What is the LV? LV is 2.3 times 10 raised to power 6 all over. What about the power? Power is 1,000. So I'll come around and drop this here, which is 1,000. Power, therefore, or rather time, therefore, is equal to, now you have this as numerator, you have this as denominator. Remember that whenever you have 10 raised to power 6, that means you have 6 zeros in the positive direction, in the positive axis. The same way you have 3 zeros here in the positive axis in the case of 1,000. So I'll come around and say 0.5 times 3 zeros are here. You can change this 1,000 to 1 times 10 raised to power 3. When we do that, this 3 can then move upward and becomes minus 3, right? You still have 0.5 here, so 0.5 times, when 3 moves up, become minus 3. What is 6 minus 3? 3, right? So this becomes 2.3 times 10 raised to power 3. Therefore, time is equal to 0.5 times 2300. What I've done now, I just converted 2.3 times 10 raised to power 3 to a whole number, which becomes 2,300. All right? So 2,300 times 0.5, T is equal to, whenever you multiply by half, when multiply a number by half of 0.5, it becomes half of what you have now. 2,000 divided by 2 is 1,000. 300 over 2 is 150. So your answer is 1150 second. 1150 second, which is the same as saying 1.15 times 10 raised to power 3 second. All right. So I'll check the options. Now, option A, option B, option C, option D. If you observe, they are all the same except the power. So if you're not careful and just make a pick, you might get the answer. You might get the answer wrong. Option A, raised to power 9. Option B, raised to power 7. Option C, raised to power 5. And option D, raised to power 3. So your answer is option D. You should learn how to convert from standard form to whole number form, or from whole number to standard form is very, very important.